are going to talk about the new electric aircraft in the future of aviation. In the past 10 years, more and more electric aircrafts are registered, and many companies are trying to use electric aircrafts instead of fuel jets. But why are the electric aircrafts are still not commonly used? Today we would like to discuss the 5 problems that electric aircrafts currently have that are holding them to be used in the aviation industry. Even though engine aircrafts are new, we all know that the way engine works in a normal aircraft is different from flying an electric aircraft. Electric motors use electromagnetic force to produce movement, while a jet is using air-fuel mixture to power the engine. Since the technology is still new, pilots with typical licenses may not contain the knowledge and theories for flying an electric aircraft. They are not trained for flying an electric aircraft. If we do not launch regulations regarding the pilot's rating, it may affect aviation safety just because the pilot is not experienced or qualified. Since the design and the operation of an electric aircraft is different from a normal aircraft engine, another electric aircraft rating becomes essential. It is just the same concept as you need to have an instrument rating to operate under IFR, so that we can ensure safety in the air. This can be referred to the CASA exams, including both flight training and theory exams. As we know that in ICAO Annex 1, Chapter 2, 2.1.1.1, it is divided into 6 categories of general licensing. Specifications like aeroplane, balloon, glider, etc. In order to make sure that the pilots are familiar with electric aircraft, we suggest that these sessions could be divided into 2 main categories: engine and electric aircraft ratings in all licenses, including RPL, PPL, CPL, and ATPL, etc. Pilots must hold the correctly rated license in order to operate the relevant type of aircraft. For the theory exams, some do not really matter what types of aircraft you operate, such as meteorology and human factors. Therefore, the pilots do not have to take the exams twice. However, for subjects like AGK and performance, those subjects are specified to the type of aircraft, so the exams for engine aircraft pilots and electric aircraft pilots should be separated. Here is an example. In CASR Part 61, Volume 2, 61.375, Bracket 4, the original version only applies to the engine aircraft. Now we add another section to applies to electric aircraft as well.
Other than pilots needing new training for flying electric aircrafts, battery progress to airport safety. We are currently using lithium-ion batteries, which are flammable and explosive. They can cause loss and damages to people and properties. It is dangerous if the batteries are overcharged or undercharged. They could overheat and cause fire. If batteries are not well handled, electric shock could cause injuries. So we need to pay more attention to the safety precautions regarding the batteries in electric aircraft in order to avoid incident happening and make everyone working there safe. We found that an incident actually happened in 2020. Aviation Alice experienced a fire accident while being tested. In January, it occurred in Prescott Airport during the power plant's testing. The battery exploded according to the fire incident report. A possible failure occurred in the aircraft battery system while the engines were being tested. So we learn from the past experience. It showed that there could be a danger if we do not set up regulations about batteries recharging and battery maintenance. There are many uncertainties about the safety of batteries, but there are no regulations about them in ICAO. So we would like to add new regulations about battery charging. According to ICAO Annex 6, Chapter 4, 4.3.7, ICAO mentioned that airplanes shall not be refueled when passengers are embarking or on board. So they only mention the precaution while refueling. Since fuel is replaced by batteries, we suggest adding regulations and safety precautions of batteries based on this sentence. We are going to make sure that the people know how to work with batteries. We are going to add a session called battery recharging. For example, there should be at least 2 people monitoring the batteries charging, since batteries cannot be overcharged or else will cause fire. If there is enough manpower to check the battery temperature regularly, we can avoid batteries being too hot. Also, after each flight, they are required to take out the batteries and bring them to an unsealed building for recharging, since there is a potential danger of causing fire if passengers are getting on board while the batteries are overcharged. So, to minimize the possibility of having incidents, it is better to take out the batteries and bring them to an unsealed building. We choose to place them in an unsealed building as we're trying to minimize the property damage if incidents happen. Also, all power must turn off before taking batteries out. We all know that if we take out the batteries with power on, we will get an electric shock. So we must make sure that we use a red flag to remind the workers to double check the power button before completing any task. Other than airport safety, we have to make sure the safety of workers. We should ensure that they are wearing insulation suits to prevent electric shocks.
What factor will affect the environment by which Hovill manufacture electrical aircraft? Sound. Aircraft noise was a sort of circus during the ICAO's early years, but this is limited to the noise produced by the propellers, which almost retained the speed of sound at the time. With the arrival of the first generation of jet plane in the early 60s, these issues became more serious. And it was intensified with the rise in the number of jet planes for international operations. Aircraft noise is influenced by a variety of factors, including the engine strength used to fly planes into the atmosphere. You can minimize noise by lowering the power. However, it might cause effect on the jet aircraft's safety features. Based on what we talked about, according to ICAO Annex 16 Chapter 2, General Guidelines, Chapter 2.3 change to aircraft type design involving no acoustical changes. Aircraft or engine model design change and airframe or engine performance changes might result in a small change in aircraft certification noise level that are not acoustically significant. These changes are referred to as no acoustical changes, called NACS. We came up with 2 solutions to make electric aircraft more reasonable in the environment. Solution 1. According to a news report Bradley GT, the electric plane acquired resolution in the sweet skies. Respondent Mark Carpatho, who run Alpine airplanes, said the noise of electric aircraft was half compared to the similar aircraft size. Although scientific experience, it is proof that electric aircraft improve noise reduction and is a potential to go even better. From scientific experience report, noise evolution of battery-powered small aircraft. It results we can ignore the Annex 16 Chapter 2.3 process because it is only applicable by fuel aircraft. Also, since the electrical aircraft improve the noise reduction, we don't see why we should keep this following this process. Therefore, I will add it, note, this process only works for fuel aircraft. Solution 2. A and B based on airplane, not included electronical aircraft. C and D based on helicopter, but we are not talking about helicopter, so we'll skip that. This solution is opposite of solution 1. Since they have few aircraft and heli in this process, we suggest to make it fair. Add E and F based on A and B, but rename airplane to electrical aircraft and also their DB unit.
One of the problems we are facing is related to the backup system in the electric aircraft, because we found that the battery is the most important part which provides power to the engine in order to operate aircraft. But what if electric engines are not working? Then how can we still operate the aircraft without the electric engine, since we cannot add the weight to the aircraft? Do ICAO mention any backup system in the aircraft? Based on what we found, the backup system is one of the most important things in every single aircraft to prevent accidents. In the normal engine aircraft perspective, according to what Max have said, in case of the miracle on the Hudson, there are two situations that prevent engine failure. An electrical system failed. Through the engine failure, there are two ways to make the aircraft safe by the aircraft design itself: a glide and using the electricity created by ram air turbine, which use the air passing under the plane like a windmill. During electrical system fail used by an auxiliary power unit to back up all the equipment or system used by electricity in aircraft. From the terms auxiliary unit is found by ICAO Airport Air Quality Manual called APU. It's a small gas turbine engine coupled to an electrical generator and used to provide electrical and pneumatic power to aircraft system when required. However, since the electric engines are using electricity, not fuel, therefore, if electric aircraft engines are facing short circuit, it could be recovered by two backup systems. First, APU, while it is providing the electricity. The second one is solar panel. It absorbs the energy in daytime and use it at nighttime. According to the plane solar impulse, it has traveled 25,000 miles without fuel or battery by using solar panel. In ICAO Annex Chapter 8 1.2, it mentioned the aeroplane shall have not less than 2 power units, so we can use that amount as a guidance, as the usage of electricity in electric aircraft is much more higher than the normal engine aircraft. Therefore, we suggest, depending on the model of the electric aircraft and considering the output of the power unit, slightly adjust the number of power units required but must than greater than 2. Plus, we have 2 more suggestions to add in the law. First, for the engine safety, the power units used in the engine and other equipment must be placed separately or in a parallel connection. The reason for that is to prevent short circuit, because if that happens, everything will be shut down since the whole aircraft is using the electricity. Second, we recommend the developer use other sources to support the engines in electric aircraft, like solar or wind power, because in the case of the power unit not working, there is still the last guarantee to run the aircraft, as though energy are not unnatural, they won't disappear.
The fifth problem is about what current standard would apply to electric motors, since the turbine engine is replaced by an electric motor. In recent years, most of the factories have started to manufacture electric motors like Tesla and Toyota. Motor composed with a rotor and starter. With an electric device, it produces a magnetic field around the rotor, then turns the rotor shaft. It's like a general electric motor. The performance of the electric motor is very similar to composed engine. Even better because motors have a light weight and don't need a gearbox to control the speed. The key point is that how can we effectively use and store the fuel cell. Nowadays, if we wanted the same performance using battery compared to the fuel, we need to get a large quantity of battery to achieve the same range. Most developers are trying to solve the problem about both mass and volume of the fuel cell, but not with today's technology. Since the challenge for the design is how to open up the range for using the electricity due to the limited capacity of the battery. For this reason, range will be the critical standard for ICAO to define. To optimize the effective range, fuel requirement is need to be considered. In ICAO Annex 6 Part 1 Section 4.3.6 Fuel and Oil Supply, we suggested using some keyword like electric motor airplane and battery. For example, 4.3.6.1, all airplane a flight shall not be commenced unless taken into account both the meteorological condition and any delay that are expected in flight. The airplane carries sufficient battery and oil to ensure that it can be safely complete the flight. In addition, a reserve shall be carried to provide for contingency. Electric motor airplane, the battery and oil carried in order to complete with 4.3.6.1 shall indicate of an electric motor airplane be at least the amount sufficient to allow the airplane. Today we have mentioned different problems and our opinion about electric aircraft. Let's have our summary. We have discussed the problem of licensing rating, battery recharge, noise pollution, backup system, and battery range in electric aircraft. We also give recommendations regarding ICAO principle which the current law didn't include. Since the technology is still fresh and immature, we mainly focus on safety approach. Do you think electric aircraft can replace the jet in the future? Hope you enjoy our presentation. Thank you.